In the last section of Module 5, we're going to take a look at applications of right triangles. So the application we're going to discuss is angles of elevation and depression. So first we'll talk about an angle of elevation. And an angle of elevation is an angle formed by the horizontal line and line of sight for an object above the horizontal. So if you're looking at a person, the horizontal line is when you look straight ahead. Then if you lift your head up, your line of sight, whatever angle you moved your head up is your angle of elevation. Then an angle of depression is the angle formed by the horizontal line and line of sight for an object below the horizontal. So similar, if you're standing there, you look straight out, that's your horizontal line. If you tilt your head down for your line of sight, whatever angle you moved your head down would be your angle of depression. So let's go ahead and do a couple examples. So Miss Huffman is 5.67 feet tall. If I stand 12 feet from the base of a building and look at the top at an angle of 35 degrees, I want to find the height of the building. So it's actually very helpful here to draw a picture. So I have my building, and then I am standing 12 feet from the base. I'm going to draw a little stick figure. I am 5.67 feet tall. I look up to the top of the building, and the angle is 35 degrees. And we want to find the height of our building, X. So a couple of things here. When I look straight at the building, I form a right angle, and I have a lovely right triangle here. Now, X isn't just my height of my building. It is actually the height of the building from my line of sight to the top. So I'm going to solve for that value of X first. So the height of my building, that is my opposite side. The distance I'm standing away from the building is my adjacent. So opposite and adjacent is tangent. So we have tangent of 35 equals our opposite side X over our hypotenuse 12. So we're going to be multiplying both sides by 12. And we get that X is 12 times the tangent of 35. So we do that in our calculator, and we get that X is 8.4 feet. Now this is not the total height of the building. This is just the height of the building from my eyes up. So to find my total height, I want to take 8.4 and add my height, 5.67. And we're going to get 14.07 feet. It's not an overly tall building. So for our second example, we have that a helicopter is sent to rescue people from a life raft in the ocean. The rescue receives the people at an angle of depression of 52 degrees. If the helicopter is at an altitude of 200 feet, how far are the people who need rescued? So I cannot draw a helicopter. So we'll just say this circle is our helicopter. And we've got our ocean, and we've got our lovely people in our life raft, which we'll denote with a circle. So if we are looking straight out, and then we look down to the people in the raft, that is our angle of depression of 52 degrees. We also know the helicopter is at an altitude of 200 feet. And we want to know how far are the people who need rescued. So that's going to be our hypotenuse X. And we can kind of think of the third side of our right triangle being formed by the ocean. So we have a right angle with the ocean. So when you have an angle of depression, it is technically outside your circle. And if you remember back to parallel lines cut by a transversal, you can think of that our hypotenuse as our transversal, and our horizontal line of sight, and then our ocean as our parallel line. So my angle of depression from the helicopter to the life raft is the same as the angle of elevation from the life raft to the helicopter. So now when I label my sides, my opposite side is the altitude and my hypotenuse is the distance that we're solving for. So opposite and hypotenuse is sine. So we have sine of 52 is going to equal 200 over x. Now this is a little different than the examples we solved before because my variable is in the denominator. We're going to start it the exact same way we did previous problems by multiplying both sides by x. But now we get x times the sine of 52 equals 200. And then to solve for x, we're going to divide by the sine of 52. So x equals, and then if we use our calculator, 253.80 feet. So that's how far away the people who need rescued are from the helicopter. So let me know if you have any questions about angles of elevation or depression, especially when it comes to drawing a picture to help you solve for whichever distance you're looking for.